All right, good afternoon. I don't know if you can feel it through the computer, but there's like excitement in the air because this is the last geometry lesson of the year. Man, and I'm not gonna lie, this is my second attempt at it today. I did it once this morning, and apparently it didn't save, so this second attempt. So here we go. Last lesson. I don't know if you're a screen counter, but where does it say? Oh, there's 6 slides. They're all easy. This first one looks a little complicated, so you might be like, oh, he's just saying it's easy. But it is. You'll see very quickly that it is very easy. So, and again, this is Thursday. This will probably get posted Thursday night. And I do apologize. There's a tight squeeze here. So this will be Thursday. The review will be posted tomorrow morning for this last test. And I know some of you all have to turn your Chromebooks in on Monday, so the test is going to post on Monday. Mr. Crabtree's going to do his video review tomorrow afternoon at the usual time, probably 2:15 to 3. So, and if you can't make that time, he'll post it. He'll do a lot of the sample problems, usually at least one of each type, and then he'll post that, so you'll have that to look at. And if you need to take it on Monday, it'll open up. I'm probably gonna have it open up at 6 a.m. Monday for you guys, because I know some of y'all have to turn your Chromebooks in on Monday. So as far as I'm concerned, you don't have to take it on Monday. Just whenever you have to take it by Wednesday, because grades end on Wednesday of next week. But take it before you have to turn your Chromebook in is what I'm saying. And some of y'all are missing, more tests. So make sure you're getting all those in before you turn your Chromebook in. All right, enough on that. Here we go. Chapter 12, Section 5, circles in the coordinate plane. And then at the very end, there's going to be one screen about lines of symmetry. So we'll talk about that when we get to it. All right, last theorem of the year, Theorem 1216. An equation, EQN always means equation, an equation of a circle with a center located at point HK. Don't know why they use the letters H and K, but this would be the X coordinate of the center. This would be the Y coordinate of the center. And if it has a radius R, then its formula, the standard form of a circle, is X minus H squared plus Y minus K squared equals the radius squared. So you got to remember to square that radius on the end. That's called the standard form of a circle. Now here's the tricky part, and that's why I put this little hint down here. Hint, in the equation, the signs will be opposite the coordinates of the center because of these minus signs, all right? So I'll show you what I mean. Say the center of a circle, of the circle we're talking about, is maybe 2, -4, all right? So what you do, this would be your H, and this would be your K. So if you were putting them into the formula, you would put a 2 right here, but then it's going to be -2. So since it was a positive 2, it's actually going to be a -2 in the equation. And just like in the the -4 is the K. So when you put a -4 here, you're going to have minus a -4, which would actually make it Y plus 4 for that part of the equation. So that's the one thing you got to be careful of. It's going to be from the point to the equation, it's going to be the opposite numbers, all right? And then, of course, on the end, like I said, that's going to be the radius, but squared, all right? And this will make more sense when we do some problems. All right, so here we go. Okay, so what they want you to do is they're giving you the 2 main ingredients for the circle, its center and its radius, and they're wanting you to write it in standard form, which I've written again right here. If you don't need to write it again, I'm going to refer to it, and you already have it in front of you. So I'm going to pretend like you hit pause, you copy down the problems. I hope you try number 1 at least, and then see if you got it right. And we're back. Okay, so here's what you should have done. So the center is at 5, -2, so that's your H, that's your K. So all you are doing, this is it. Students have been asking me the last 2 days, do I have to solve anything? No, you don't have to solve anything. You just put the numbers where they go, but you do have to square the radius. That's the only thing. So my H is 5, so I'm going to literally replace this H with a 5. I'm going to put the 5 right there. I'm going to put the -2 right there. And then this 7 is going to go right there and get squared. So your answer should have been, since this is a positive 5, it should have been X minus 5 parentheses squared plus, we move on to the y part, it would be y, and since that's a minus 2, it's actually going to be a plus 2 quantity squared equals, the radius is 7, so when I square that, I would have a 49 on the end. So I hope you attempted it, and maybe you even got that. If you didn't, just fix it a little bit. And if you want to hit pause again, now that you might feel more comfortable how to do it, you can. And try these next two. All right, so hopefully you've done that. This one, the center is 3, 0. So our h is 3, our k is 0. And since that's a positive 3, it's going to be x minus 3 quantity squared. And this one's a little tricky. Well, not tricky, but I'm going to show you what's going to happen here is you would say y minus 0 squared. And then on the end, you have this 6 for the radius. So, of course, you would square it, and it would become 36. Now, on the test, being a multiple choice test, they like to always simplify their answers. Meaning they're not going to leave stuff that's not necessary in the answer. They're going to simplify it down. And this y minus 0, the minus 0 is not necessary because y minus 0 is just y. And that eliminates actually even the need for parentheses. So if your answer did come out like this, on the test, it'll probably look more like just y squared. Because y squared and y minus 0 quantity squared are the same thing. All right, so it's going to probably look more like that. All right, now the last one, some of y'all might be a little bit nervous because that square root on the radius, but you know what we're going to do to get to the number on the end. We're going to square it, and when you square a square root, I mean, that just cancels out. So hopefully this is what you did. Since we have a negative 2 and a negative 1, it's going to be x plus 2 quantity squared. And then you got a negative 1 for the y, so it's going to be y plus 1 quantity squared equals, and now here's what happens. You know that's the radius, but what the number that goes on the end is the radius squared. So what you would do is you would square that, and you've heard me say this numerous times over the years, when you have a root and a square, they cancel each other out. Roots and squares cancel out, so you're just left with a regular 2. So that's just going to be a regular 2. And bam, there we go. Now, on the next screen, they're going to ask the same thing, except for in the reverse order. So on this screen, I gave you the center and the radius, which are the two ingredients you need for a circle equation, the center and the radius. So I gave those to you, and then you gave me the equation. So you know what they're going to do on the next screen. They're going to give you the equation and ask you to pull out the center and the radius. All right, so here we go. And again, I'll step to the side. You hit pause. You copy them down. Hopefully you'll try at least the first one. And let's see what you got. So the equation, it says x plus 6 squared, y minus 2, blah, 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 81. So remember, the center is the opposite of these two numbers. So if that says plus 6, the center must be at negative 6. And since that's a minus 2, positive 2. All right, and then remember, this number represents the radius squared, so I need to square root it to get the actual radius, and I think everybody knows the square root of 81 is 9. All right, I hope you had that. And then in number 2, there's a little curveball they throw at you because the x doesn't have a number attached to it in parentheses with it. So I think from that one example we did on the previous screen, you know that means it's 0, right? There is no number with the x in parentheses, so that means his coordinate is 0. And then this 11 is positive, so it'd be negative 11. And then, again, that's the radius squared, so we square root it to get 8 for the radius. And then the last one is my favorite one on the screen. It didn't stop anybody today or yesterday. They all just said, that's easy, Mr. Metcalfe, and I hope you did too. They notice there's no number on the x, no number on the y, so that means 0, 0. So the center of this circle is the origin, meaning if you were graphing it, the center would be right there in the center, or what we call the origin. Now, the number on the end is 25, so to get the radius, you'd root it, which of course would be 5. So if you actually wanted to sketch this one, well, actually you could sketch any of these now, but this one would be really easy. It's going to be a circle going, with the center at 0. If it has a radius of 5, you'd kind of count over here 1, 2, 3, 4, 5, and put a dot. You might count 1, 2, 3, 4, 5, put a dot. 1, 2, 3, 4, 5, put a dot. 1, 2, 3, 4, 5, put a dot. And then you'd have a nice little circle like that. All right. So, and that's what's going to happen on a later screen. Maybe not the next screen. Maybe it is. I can't remember. But you can, once you have an equation or you have this information, you can actually graph the circle. And you know what I think is going to happen on the next screen? I think they're going to have a graph of a circle, and we're going to have to work backwards to get to find out the radius and the center, and then come up with an equation. I believe that's what's going to happen. And boom, I'm right. So we got a circle, 2 circles actually, and here is the center. You need that, and you need the radius. Now, this might be hard to do on a screen, so you could pause it and literally put your finger, your pencil tip lightly. Don't write on your screen or anything. And count the radius, boom, 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 like that. And hopefully you remember about plotting points, how to get to what this center's coordinates are. Well, if you've forgotten, your first number is your x, so your side-to-side number, and it's in the dead center, which means the x coordinate of the center is 0. It's not right, it's not left, but it is down. So the y coordinate is your up or down, and it appears to be down 1, 2, 3, 4. Down 4, you all probably remember, means -4. So there's the center, and the radius would be, now be careful, because at least this happened at least a couple of times today. People, when they're counting their radius, are off by 1 because when they touch their pencil to the center, they say 1 before they have actually moved a unit. So don't do that. So when you put your pencil there, don't say 1 until you've moved 1, 2, 3. So the radius appears to be 3. I always like to check it by going one more time in the vertical direction just to make sure. So 1, 2, 3. Yep, it's pretty safe to say his radius is 3. All right. Now, we've done the hard part. Now we just got to put that information into the equation. Here it is. There's the standard form. We just put it in that equation, and that's what they want. So if the center is 0, -4, that means the x has no number attached to it, so I could just write x squared. You could put x minus 0, quantity squared, if you wanted. That's correct. It's just not simplified all the way. Then the y is a -4, so I'm going to put y plus 4 quantity squared, and I'm going to make it equal. And remember, this number on the end is the radius squared. My radius is 3, so 3 squared is 9. And there's the equation of that circle right there. So I went from a picture to get the info all the way to the equation. Now, hopefully everybody else can do this one, and I'm going to pretend like you tried it, and we're ready to go. All right, so first thing, what is his center? Well, his center is going to the left. It's going to the left 1, 2, 3. That would be -3. And then it goes down 1. Down 1, I think we all know, means -1. All right, so there's the center. Again, we need the radius for that number on the end of the equation. So I put my pencil without saying 1 until I've actually moved 1. The radius is 1, 2, 3, 4. To make sure, 1, 2, 3, 4. Pretty darn confident it's 4. All right, put that information in into the standard form equation. I got negatives on both, so that means in my parentheses I'm going to have positives on both. So it's going to be x plus 3 quantity squared plus y plus 1 quantity squared equals, and the radius is 4, so the number on the end would be 4 times 4, which is 16. Bam, I hope you had that. Hope everybody got that number. All right, almost done. We're coming down the home stretch. The last, it's the second to last screen. We had fun with this one in class today and yesterday, because on this last one, I actually let students come to the board and do stuff, and they're excited. They're always excited when they get to use precious. Yeah, they always like that. So here it is. we've got an equation. So they want you to take kind of the opposite of what we just did on the last one, where there was a circle and we worked backwards and got the equation. Now there's an equation, they want us to graph it. So each class had 2 students do this, 1 and 1, and it was pretty exciting. Some people did some really good circles. Some of them, were kind of crazy looking, but, it was all fun and games. Good. All right, so his center, we got a -3, so that means +3, and we got a +2, so that means -2. And then this number on the end is a 25, so I would root it, which means the radius is 5. All right, so now I've got my important info. I'm going to graph 3, -2. 1, 2, 3, 1, 2. His center is right there. Now, on this one, when I'm trying to sketch a graph, I'm not just going to go one way and another way. I'm going to do all 4 points. And here's what I mean by that. Here's my center, and the radius is 5. I'm going to go 5 to the right. 1, 2, 3, 4, 5. Put a little mark. I'm going to go 5 up. 1, 2, 3, 4, 5. And then, it almost goes into the equation. I'm going to go 5 left. 1, 2, 3, 4, 5. Oh, man, almost goes off the grid. And then lastly, 5 down. 1, 2, 3, 4, 5. And that gives me a much better chance of making a semi-decent circle. We'll see. Of course, I'm on camera now, so I'll probably screw up. But here we go. It would look something like this. Ooh, not too bad so far. Oh, and boom! That's a pretty good one. That's that circle based on this equation. So hopefully you were able to do that. If you weren't, now that you've seen how it's done, please attempt this one on your own and see if you got it right. Okay, here we go. So I'm going to switch over to blue because this one looks like it's a blue circle. At least the equation is. So the number attached to x is a -1. That means its center is +1. And then y has no number attached to it, so we know that means 0. All right, so the center is at 1, 0. And again, this number represents the radius squared, so I root it. Square root of 9 is 3, so the radius is 3. I know on your homework problems there's going to be a couple of problems, not ones where they ask you to graph it, because this would be hard. There's going to be some numbers that are not perfect squares. I think there's only 2. I think one of them's a 5, and then they're like, okay, what's the radius? If that number on the end's a 5, and you're like, to get the radius, I square root. Well, it's not a perfect square, so on that problem, just if the radius would be the square root of 5, you can just leave that as your answer, square root of 5. All right, and here's what I mean. It'd be like the square root of 5. That's okay to leave it. If you want to decimalize it with your calculator, you can, but this is good enough. I think there's only 2 problems that do that. Okay, and that takes us to our, oh no, I haven't graphed it yet, my bad. I am getting ahead of myself, so let's get that scrap work out of here. And my center is at 1, 0, so that means right 1, up or down none. So bam, there's the center. My radius is 3, so I go 1, 2, 3, put a dot. Up 1, 2, 3, put a dot. Left 1, 2, 3, put a dot. Down 1, 2, 3, put a dot. And I make my blue circle, which is looking sort of decent. Oh, missed it. Looks pretty good. So there you go. And that takes us to the last thing, the last concept of the year, this thing called line of symmetry. I'll click on it so you can start writing it down if you so desire. There it is, and I'll step out of the way in a minute. But what a line of symmetry is, if you have a shape like maybe a piece of paper, a line of symmetry is just where you could fold it such that one side perfectly matches up with the other side. Like, if I took this slice of paper and I folded it right here, it would match up perfectly. So that means this would be the fold itself would be a line of symmetry. And different shapes have different amounts of lines of symmetry. Some have none. Some shapes you can't ever fold it and make it match up perfectly. Others have one. Some have multiple. There's a wide range of amount of lines of symmetry. So I'll step out of the way and let you have a chance to copy it and draw these 6, and then we'll be done with new stuff for geometry. Man, I hope you're excited. I'm excited. I appreciate you guys. I know this has not been an easy year with the COVID and online and all kinds of stuff, and at times different people, teachers, students, everybody, we've been stressed out because it was just kind of a crazy year, but here we are. We're on the last screen of geometry. Thank you, those of you all who've been watching these videos faithfully and doing your homework. I appreciate that. And I want to wish you a happy summer and all those good things. So let's do this last screen, and hopefully everybody will do well on this last test. I do believe it's going to be pretty easy. Like, the Chapter 12 Part 1 test, the in-person people knocked it out of the park. That was like the highest grades for almost every class. They had their highest grades on that one. I think this test is going to be just as easy, if not easier, so hopefully we'll end the year with a really positive note. Okay, so line of symmetry. It's a line that when a shape is reflected across it, okay, reflected is a fancy way of saying folded. If you fold it on that line, it'll map perfectly to the other side. Now, there's a couple of things. One thing I want you to know, it doesn't necessarily, just making it into two equal parts is not enough, all right? There might be a shape where if you fold it a certain way, it would break it into two equal parts, but when you fold it or you reflect it, those parts don't match up. So that's not a line of symmetry. It's got to, when you fold it, the pieces have to match up perfectly. They could be the same size and not match up perfectly, then it's not a line of symmetry. All right, so let's look at this yellow triangle. I'm going to pretend like you hit pause, you copied it, you tried them. I hope everybody tried all of them. And then, like I said, you're at your own home. Nobody's going to know if you got them right or wrong. So just take a shot at them. And the first one, I hope you said 1. Because there's only one way you could fold this triangle, and that's right down the middle vertically. Because when you do, then this side will match up perfectly with that side. If you tried to do it horizontally, you tried to fold it downward, you'd have a point down here and a bar, and that ain't gonna match up. So it's only got 1. Now, before we move on to the others, now that I've shown you how to do one, I'll tell you what I do. I always test it this way. I always see if a vertical line will do it, and if it, and then I see if a horizontal line do it, and then I try, will a perfectly diagonal line do it? Sometimes the diagonal line, then there's a diagonal from this direction, and there's diagonal from that direction. And then if all those work, then man, you start trying other stuff, see what happens. And usually that's usually enough. But let's look at these last 5 together. So we got this rectangle here, and for the rectangle, I hope you said 2. It's got the vertical one. This would fold perfectly over there and match up with that one. I hope you also said the horizontal one, because if you took that and folded it down, it would match up. Now, some of y'all might try diagonal, and I hope you tried it. And when you did, I'm going to do it dotted because the diagonal one does not work in this example. If you folded it diagonally like that, it does make it into 2 equal parts, and that's why I emphasize this at the beginning of the screen. These 2 pieces will be the same size and everything, but when I fold it, this point right here is going to fold down to here where there is no point, and this point here is going to fold up to here where there is no point. So they don't match up. So that diagonal is not a line of symmetry, just the horizontal and the vertical. So he has 2. Well, I never did write 1 next to him. All right, so he's had 1, he has 2. And also, don't think that all triangles have 1. Some triangles don't have any, but other triangles have more than 1. So it depends on the type. This type of triangle only had 1. All right, number 3 looks like a square. It is. So how many lines of symmetry do you think you have a square has? It's 4. Bam. You've got your classic vertical. You've got your horizontal. And on a square, the diagonal will work. So if you folded it right there, because this time when you do, that point there will fold perfectly down to that one. And that means usually, not always, it means usually this diagonal will work too, and it does. So when you fold it that way, that matches up with it. So a square has 4 lines of symmetry. And then we come down here to this weird guy. This is anybody who reads comic books or stuff like that, this is called a comic, conversation bubble, I think is what they call it. This is, and this little stick points to whoever's speaking's mouth, so you know who they're saying it. And for that, because of that little thing, it has 0. There's no way you can fold it. If you try the vertical, this piece folds over and there's not a piece to match up over here. If you try it horizontal and you fold that up, again, that stick, there's nothing to match up with that. So it has 0 lines of symmetry. And now number 5 is my favorite one on this screen. We've had some interesting guesses today, and every class eventually got to it. Some of them got it right on the first try. That was awesome. But some of them, it took us a few guesses. We've had everything from 2, somebody said 4, and again, I understand all those answers. But I hope you said, and another popular one is 360, and you know why that makes sense, right? Because we've been talking about a circle has 360 degrees, so maybe you could fold it on each degree, or 180 makes sense because, really, since there's 360 degrees, this fold would match up with that one down here, so maybe it's only 180. Actually, none of those are correct. It's actually an infinite amount. I mean, you could fold this thing vertical, horizontal, diagonal at a 45, diagonal at a 45. You could then break those in half, and I mean, you can just do a lot of folds with this one. Matter of fact, like I said, you can fold on each degree, you can fold on half degrees, you can fold on quarter degrees, so it's infinite, all right? So a circle has an infinite, which is, for math people, we draw an 8 laying down, taking a nap. That's an infinity sign, all right? And then 6, the moment has come. We're about to wrap up geometry right here. Hopefully, that's an oval, by the way. I hope you can see. I'm going to step to the side. Yeah, I see a glare. That's an oval, and an oval, at least this oval has 2. It's got the classic vertical. It's got the classic horizontal. And if you drew a diagonal one, I think you would see that it wouldn't fold over. It might have equal parts, but when you folded it, it wouldn't match up right. It's only got the 2. There may be ovals. No, I don't think so. I was going to say for a minute, I thought maybe there's an oval that could have 4, but thinking about it, I don't think that's possible. Don't quote me on that. But I don't think so. All right, if you have any questions, shoot me an email. And again, I'm sorry for the tight squeeze, but the whole Chromebook thing getting turned in has done that. So the test will go live Monday morning. You're not under any responsibility you got to do it Monday morning unless your Chromebook has to be turned in Monday afternoon, and then you better do it Monday. So any assignments, you got to get them in before you turn in that Chromebook. And if you have some really super cool teacher who's letting you turn it in on the last day of school, that's no good. Everything's got to be due by Wednesday, 11:59 p.m., and that's it. I have to have time to grade it, put it in Power School, and we can all live happily ever after. But once again, thank you for all your patience. I know my videos have probably dragged on. I'm making this one drag on right now, but of course, why not? It's the last one, right? So thanks again. Have a great summer, and thank you for doing online geometry. Bye.